Learning the language of sequences. Sequences have their own notation and vocabulary that help describe them, such as a term and a term number. The questions below help you learn this vocabulary. So consider the sequence of numbers. -9, -5, -1, 3, and 7. Is this pattern arithmetic, geometric, or neither? How can you tell? This pattern is called arithmetic because how it's changing each time is a constant rate. In this case, to go from 3 to 7, it's adding 4. To go from -1 to 3, it's adding 4. To go from -5 to 1, it's adding 4. The first term of the sequence is the first number that you see. The first term is the first one shown. In this case, it's -9. Question C. What is this? When the sequence generator adds a number to each term, the value that is added is called the common difference. It's the difference between each term and the term before it. So the common difference in this case is that plus 4. It's constantly adding 4. This is also called the sequence generator, because to generate the sequence or to create and continue the sequence, you would have to add 4. So the sequence generator is add 4. Record the sequence in a table. So in a table, we would say that the first term started at -9. The second term is -5. The third term is -1, then 3, and then 7. So you notice in the table, this n stands for what term number you're on, and t of n, or t parentheses n, is what's the number that you see in the pattern. So then question E asks, what is t of n when n is 0? So if we had to work backwards and put a 0 position in our table, if we had to go backwards previous to the -9 by 4, it would have been the number -13. -13, if you add 4, would get you to that -9. So when n is 0, it's -13. Graph the sequence. If we saw these plotted on a graph, the 0th position would be down here at -13. The first term is -9, -5, the third term is -1, the fourth is 3, and 7. This line, these dots, are linear. They make a straight line because it's constantly going up by 4. We are not going to connect the dots because you can't have the numbers in between. A sequence is only these specific locations, not the spots in between. And we'll skip the rest of these questions. So let's look at another sequence. Here the pattern is -4, -1, 2, and 5. So what is the first term? They call that T1. So term number 1 is here, -4. Then they ask us what would be term 0, meaning prior to that, what would be the 0th number that we need to fill in? Well, we need to find what this common difference is. How do we get from -4 to -1? -1 to 2, or from 2 to 5? The pattern is adding 3. Each time it's adding 3 to get to the next number. So we'd have to work backwards from -4, go backwards by 3, and our 0th position would be -7. -7. And the common difference was 3. If we want to write this as an equation, we'll write just our regular y equals mx plus b. So we're going to say y equals the 0th position, the starting point is -7, and the rate of change is adding 3 each time. So we'll say 3x. So that common difference, what it's changing by each time, goes as the slope of the equation, and that 0th position, what it would have started at, is the y-intercept of the equation. The last question asks us, is it possible for the sequence t of n to equal 42? You could continue this pattern on and on and on, use a calculator, start at 5, add 3, add 3, add 3, add 3, and continue adding 3 until you get to 42 and see if it works. Or you can write it as an equation. We want to know, can the 3x minus 7 equation ever equal 42? And we can just solve this equation. Add 7, 42 would make now 49 if we add 7. And then if we divide by 3, we get 16.33. And that doesn't make sense. I can have the 16th number, or I could have the 17th number, but I can't have the 16.33 of a number in a position. So the answer to this question is no. It will not ever reach 42. From 5, if we keep adding 3 and adding 3 and adding 3, we don't get to 42. We get to 41. And then from 41, we would add 3 more and we'd get 44, and it would jump past. So I'll set up one from each of these problems, and it will be your job to finish them. Number 65, determine whether 447 is a term of the sequence. If so, which term is it? So I'm wondering, can this pattern, which for information-wise would have started with the 0th term is -3, and the pattern is to add 5 over and over and over again, will it ever get to 447? So I'm just going to take my equation, 5n minus 3, and wonder, can it equal 447? So solve that for n. Add 3 on both sides. 450 equals 5n. And divide by 5, and we get n equals 90. So in this particular sequence of numbers, starting at -3 and increasing by 5 every time, the 90th position in the sequence would have gotten me to 447. You can try part B. Next question, number 67. Find the sequence generator for each sequence listed below. Write an equation for the nth term of the sequence, keeping in mind that the first term is t1. So if I look at the pattern in A, I notice that it is increasing and going up by adding 3 each time. So I need to work backwards and find the 0th position, because 4 is the first term and 7 is the second term. So from 4, if I go backwards by 3, the number would be a 1. And so now I can write my equation. Y equals, the starting number is 1, and the rate of change is 3 every single time. So my equation is going to say 3x plus 1. The 3 is for that common difference rate of change. And the 0th position, when we worked backwards by a spot, is that y-intercept or starting point. It is possible for the pattern to be going negative, and then your slope or your rate of change, your common difference, would just be a negative number or a minus.